So today we will be covering a matrix median problem. What the problem states is something. So you will be given a 2D matrix. First constraint. Second constraint. This 2D matrix will have n cross m elements. As we all know, this is no surprise. But there is a catch here. N and m, these two elements will always be odd. So this brings us to the third constraint, that the number of elements will always be odd. Why? Because n cross m, that is odd cross odd equals odd. ठीक है? Okay. Let's straight away discuss about the approach that we will be following. The binary search approach. Why binary search? Okay. We all know that we need. अच्छा ठीक है. Why binary search? I'll be answering this in a while. What can be the, because binary search is the most what should I say, optimized approach. But before coming to this optimized approach, what can be the brutest approach that you can take? So the brutest approach that you can take for finding a median, and I am assuming that we all know about median. If we don't, then I can just take an example. I can just take an example for an 2D matrix. Let's say we have, let me just scroll here. Let's say we have our 2D matrix as 1 2 3 4 5 6 7 8 9. So the brutest approach for finding the median, and we all know what is median. Median is the median for a odd length array is the centermost element, correct? So what is the brutest approach that I can think of is append all these elements to an array, append all these elements to an array. Let's say ARR, create an array out of all these elements. So go ahead, append all these elements to this array in a sorted fashion. Seven, 9. ठीक है? And we all know the size of this array. Size of this array will be rows into columns. So 3 into 3, that is 9. What will be the centermost element? By 2, that is the mid. Okay, so we all know 5 here. This will be the median. ठीक है? 4 elements here. This becomes the centermost element in an odd length sorted array. So 5 is our median. Good. So this will be a brutest approach. Arrange this matrix into a sorted fashion array, and then just output the middlemost element, that is the n by r into c by 2th element. Okay, 0 1 2 3 4, r into c by 2th element. ठीक है? You will be getting a 4 here, and then just output this. That is it. Okay, so this incurs a time complexity of first traversing traversing over the entire array, entire matrix. That gives us the time complexity of n into m. Then appending it to the array gives us a time complexity of again, or a space complexity. This is a time complexity. Appending it to an array, that means taking an array of size n into m incurs a space of n into m space. Sorting that array n into m log of n into m. ठीक है? This is the total and this is also the time complexity, space and time. Okay. Now the thing you must be thinking that why are we doing this part n into m log n? We can just append, we can just iterate in our matrix in this fashion. We can just go like this, then again starting from here. But who told you that 1 2 3 after 1 2 3 the below array will always be 4 5 and 6? Who told you? I just told you that these will be row wise sorted. So you can have a matrix like this. You can have a matrix like 4 5 6 1 2 3. Got my point? So you cannot always depend on traversing the array in this fashion and then expect that this element will always be lesser than this element. You cannot expect this. Okay, that is it. That was for the time complexity and space complexity for the brutest approach that we will be taking. Now, what is the binary search approach that we will be taking? Let's just discuss on that part. Let me just take an example 2D matrix, the same one that we took earlier. 1 2 3 4 5 6 7 8 9. Okay, just think of this part. How was the median being decided? This is the mid. This is the number of elements that will be residing to the left of median. What is this? This is equals to 4. That means to the left of my median will always lie 4 elements. To the right of my median will always lie 4 elements. Discount state this only, na? To the left, to the right, to the left 4, to the right 4. Correct? Now, think of this part. Just think of it. We are having our array sorted in this fashion. Like, don't think of it as sorted. Just think that I am arranging all the elements right in front of you. 1 2 3 4 5 6 7 8 9. Okay, for each element right here, for each element right here, let me just, for each element right here, this, we have, what we have stored is a count. What does that count indicates? So let's say we have stored a count x here, or if I just write it here, What does this x states? This x states the number of elements lesser than equal to my current number. Okay, this x array states, or this x array contains the number of elements for each element. For each element it contains, for each element it contains the number of elements lesser than equal to this number. ठीक है? So let's say कि we have a hypothetical number. We got a hypothetical number. We got a hypothetical number as 16. ठीक है? So don't think of this as an array. Let's just erase this. I think you can forget this. The more simpler thing to remember will not be this. Just remember this matrix. Just remember this hypothetical number. ठीक है? Hypothetical number 16. Hypothetical number is 16. I am having a helper function in which if you pass me the matrix M, in which if you pass me the hypothetical number, this method returns the number of elements lesser than equal to hypothetical number. The number of elements less than equal to the hypothetical number, and these number of elements are calculated from my matrix M. Got the point? So what does this helper function do? This helper function, it has its own methodology. Let's say as of now कि it iterates over the entire 2D matrix. In whichever fashion it wants to iterate, it iterates and calculates what? I'll not repeat this. I'll just calculates this right here. Okay. So far so good. Now let's say in each iteration you are generating this hypothetical number. You are passing this hypothetical number to the helper function. The matrix, the hypothetical number. The helper function returns you with a count. What can you do with that count? We just tell me one thing. Do we know or do we don't? Do we know beforehand how many elements will lie to the left or right of my median? Do we know this or not? I think we know this. Why? We just talked about this right here. If this is an odd length array matrix, from the matrix, from all these elements, this is an odd length array, then the number of elements by 2 gives me the number of elements to the right of my median and the number of elements to the left of my median. This is the mean thing. This is the number of elements. So if this is the number of elements to the right and left, should I not just keep a watch on this? Should I not just keep a watch on this only? Getting my point? If somehow I can find a number, see, I know that this needs to be sorted. After sorting only we will be receiving 5, and after sorting only if we receive 5 and we know that let me take 5. So in our case we will be going reverse. In this case what we had, we have a sorted array and then the median will lie here. But now what we will be doing, we will be generating these hypothetical numbers. We will be traversing. Let's say our hypothetical number is, for an example, 8. We generated an hypothetical number 8. We traversed in our entire matrix and we asked how many elements are lesser than equal to my hypothetical number. How many elements are lesser than equal to my hypothetical number? So it gave me an answer of 1, 2, 3, 4, 5, 6, 7 and 8. So if I pass this to my hypothetical to my helper function and that returns me 8, I know na ki there are 9 elements, correct? My median will be that number which has 4 elements at least lesser than equal to it. Okay, 4 elements lesser than to it, 4 elements lesser than to it, or equal to 4 elements lesser than equal to it. So sorry, not at least, at max. So my median 5 right here, my median x here, or 5 only, 5 has 4 elements lesser than equal to 5. Getting my point? So and also 4 elements will lie after him also. 4 elements will lie before him and 4 elements will lie after him. So what I need to find that hypothetical number. Which has 4 elements lesser than equal to my hypothetical number. 4 elements lesser than equal to my hypothetical number. And if I am saying 4, why? Because R into C, the total number of elements by 2 was 4. So if I just generalize, what I want, I'll just write it. I want n into m by 2. These many numbers lesser than equal to my hypothetical number. I am in search of this hypothetical number that gives me this result. Okay. And this result I am counting with my helper function. If I am able to achieve this result, then voila, it is my assumed median. Okay, getting my point? Let's say I found 5. Okay, I found 5. I searched into the entire matrix. I found with my taking hypothetical number as 5, I am getting a result as 4 elements lesser than equal to 5. I am getting that result. That can be a potential answer. That can be a potential answer. Okay. So if that is a potential answer, what can I do? I can go ahead more. I can go ahead more. Okay, okay. I think this is okay. How many elements will lie to the left or right side of my median? We just discussed about this, and that will always be n into m by 2. This is the answer to this question right here. Okay, we are in search of this. We are in search of this. Okay. Now what my task will be? What my task will be? My task will be, hey man, generate a hypothetical number, pass it to my helper function, get the count, of lesser than equal to numbers, or should I mention lesser than equal to hypothetical numbers, the count. I think you get it. If my count by count I mean the number of numbers lesser than equal to my hypothetical number, the number of numbers lesser than equal to my hypothetical number. If my count is less than equal to the assumed count. What is the assumed count? Anyways, our assumed count is fixed. What is our fixed assumed count? Fixed assumed, or just assumed count is assumed count is just a fine integer. So assumed count will always be n into m by 2. Correct. It will always be n into m by 2. Correct. As and when I find a count that is lesser than equal to my assumed count, I am writing this as AC. Okay. As and when I find a, if this returns me a count now, this returns me a count, and that count is lesser than equal to my assumed count. Okay, what will I do? It is lesser than equal to, no? It is lesser than equal to. Then bro, do one thing. Increase my hypothetical number. Increase my hypothetical number. Hypothetical number plus plus, or whatever you do, just increase it. There should be a way of increasing. That way we will decide. But as of now, increase this. Not only plus plus, this will only increase it by 1. But yeah, you got the point. Hypothetical number needs to be increased. Okay, why hypothetical number needs to be increased? Because if my hypothetical number grows, this count will also grow. Getting my point? If my hypothetical number grows, the count will also grow. Okay? If the count is less than assumed count, that is, you took a hypothetical number. Sorry, is greater. My bad. If my count is greater than the assumed count, that is, you took a hypothetical number, and what the count that you are getting is key. The number of elements, where is that part? Not this part. You calculated the number of elements, and now what you are getting is my hypothetical number was 9. The number of elements lesser than equal to are 8, and 8. Let me just scroll down. I think you got my point, what I wanted to say. If you let's say got 8, then 8 is all anyway greater than 4. Matlab in our example, we assume that 4 elements will be on left, 4 elements will be on right, and the middle will be the median. So 8 is always a greater element. That was because my hypothetical number was big. So for the sake of humanity, let us decrease my hypothetical number. Got my point? Decrease my hypothetical number. This is the pseudo approach that we will be following. I think I am clear as of now what we will be doing. You all very much know about the binary search part, how that will be done. I will just not be taking that much time. I think the logic is clear what we will be doing. This is also clear. I covered this part also. Yeah. Now I think it will not take much time. I can just talk about the code that we will be writing, or I have written it. I'll just show it. Yeah, it's right here. I'll just be taking a snapshot of this logic and will be posting it into a doc, and that doc link will be below the video. But yeah, as of now, let's see the approach. We have the gist now. We have the gist what we will be doing. So, okay. Okay, this is the code. See, I think this does not require much of a talking, but yeah. So if you see right here, we are given with the matrix. Okay. We have our high, we have our low, and I think I should increase the size of my pen. But yeah. Now what we are doing is we have our high, we have our low. We need to decide what will be the range of selecting that hypothetical number na. So our range will be the smallest element of my matrix and the largest element of my matrix. The smallest element of my matrix, this will calculate the smallest element of my matrix. This will calculate the largest element of my matrix. Okay? This is the binary search that we are doing. This is the hypothetical number that is being generated every now and then. This is the helper method that is counting the lesser than equal to part. This is the point where we are deciding if the count from my hypothetical number is lesser than equal to the required, then increase the hypothetical number. If the count is greater than, then decrease the hypothetical number. Correct? And this depends on you, what approach you will be taking to calculate this thing, the lesser than equal to part. So you can iterate over the entire matrix, that is upon you. That will incur a time complexity of n into m, because you will be iterating over the entire matrix. N into m will be the time complexity, because you will be iterating over the entire matrix and then finding out how many elements are lesser than equal to my hypothetical number. Your wish. What I have done, there is a method named upper bound. We know that each row is sorted. Our matrix is row wise sorted. Row wise sorted. So this line right here gives me the count of elements lesser than equal to my hypothetical number in each row. ठीक है? This line right here, I'll just explain what this line does, but yeah, this line right here gives me count of elements lesser than equal to my hypothetical number in each row, because each row is sorted. Upper bound only applies to a sorted array because this is a binary search function. As and when we are getting the count of all the elements lesser than equal to my hypothetical number, add it to the sum. After adding it to the sum, finally when you have traversed over all these rows or all the arrays, because if this is your matrix, array 1, array 2, array 3, correct? You matrix at 0th will be this array, matrix at 1th will be this array, matrix at 2th will be this array. So as and when you have traversed over all the arrays, just return the sum. What does this sum indicates? This sum indicates the total number of integers. I'll just take black. What this sum indicates? Total number of numbers lesser than equal to mid that we have said. But what is the actual variable that we are talking about? Hypothetical number. So lesser than equal to mid or my hypothetical number. The counting strategy totally depends upon you. This just reduces the n into m thing. So मतलब by how much? Let's see. मतलब in n into m what you would have done? Traverse over the entire matrix. ठीक है? In this part, मतलब if we use the upper bound thing, what is the time complexity that we are incurring? Is n into log of m. That is the total time complexity we are incurring. This is also not exact. मतलब if we just bifurcate it, log of m plus m plus m, that in turn is equals to log of 3m, that is more or less equal to log of m. So that is why n into log of m is the total time complexity of my helper function. And here the binary search that we are doing, this right here, this also has a time complexity of this has a time complexity of this part right here has a time complexity of log n into m. मतलब worst case can be this, because मतलब yes, worst case can be this. So what is the total time complexity that we are seeing here? Because this is also doing a binary search only, na? This is also a binary search. Binary search always has a time complexity of log m, correct? And मतलब this will incur this much time complexity. So what is the total time complexity that we are seeing here? What is the total TC? Let me just write it with blue. The total TC is log of n into m into n into log of m. This is my total time complexity. So let us see what is the improvement that we did. Matlab, I know you have guessed this part, but if I just write it more clearly, then n into n into m is always a number. So we can just okay, never mind. Log of n into m, we can just assume it to be a delta number or theta number or whatever we want, but yeah, ठीक है, never mind. Log of m. Okay, this is the final time complexity that we are seeing. Versus what was the old time complexity that we were seeing right here. If I just zoom in this part, sorry, n into m into log of n into m. Seeing this, n into m into log of n into m. Versus n into m into log of n into m. I think you all can guess. We have reduced it by a linear fashion. See, if you just compare what all differences we are having. N right here, n marks with n. So this is sorted, no reduction. This right here is sorted, no reduction. But the main thing, this right here, you can see what we did from a time complexity of m, we made it possible to a time complexity of log of m. So a shift from linear to logarithmic, that is huge. That is a huge win. I consider this as a huge win. So that was it for the video as of now. I think the approach was clear. You guys can study about this method. This is no magic. This everyone knows. So if you are studying about matrix median, then obviously you know about this method. If you don't know, just chat GPT it or just Google it. You will get it. But yeah, I think the logic was clear from my part, and that was it for the video. Thanks.